In this video, we're going to learn how to find one-sided limits. Let's begin by considering the function f of x equals x plus 8 times the absolute value of x plus 7 divided by x plus 7. We're looking for the limit as x approaches c. For this example, let's allow c to equal -7. We note the expression, the absolute value of x plus 7, is equal to x plus 7 for all values of x that are larger than -7. So if we evaluate the limit of our function as x approaches -7 from the right, then we have x plus 8 times x plus 7 divided by x plus 7 These values cancel out to 1. Now we are left with the expression x plus 8, for which we substitute -7 in place of x. -7 plus 8 equals 1. Therefore, the limit of x plus 8 times the absolute value of x plus 7 divided by x plus 7 as x approaches -7 from the right is equal to 1. I want to back up for just a second and note one very important step. Notice that I canceled out our x plus 7 terms before I entered -7 for x. If I had not done this, then I would have had -7 plus 7 over -7 plus 7. Since -7 gives us a 0 denominator, this would be undefined. But if I hadn't noticed that, and I had simply allowed each of these to equal 0, and then multiplied 0 times x plus 8, I would not have found the correct limit. So 1 is our limit as our function approaches -7 from the right. Now let's take a look at the limit as we approach from the left. Looking again at the absolute value of x plus 7, for values of x that are less than -7, the absolute value of x plus 7 is equal to negative x plus 7. In earlier algebra classes, you might have considered the negative sign to be the same as saying -1 times x plus 7. At this point, you should be beyond having to use that type of notation. However, just keep in mind that the negative sign is in front of a set of parentheses. So now let's evaluate our left-hand limit. So we have f of x equals x plus 8. And now, since we're approaching from the left, this will be multiplied by negative times x plus 7 divided by x plus 7. We'll cancel x plus 7 over x plus 7. This leaves us with x plus 8 times negative 1. Substituting negative 7 for x gives us gives us positive 1 times negative 1. And our limit, in this case, when x is approaching from the left, is equal to negative 1. This concludes our example of limits approaching from the left and the right. I hope you found it helpful, and we'll see you next time.